13, 14, and 15, we are doing the double angle identities. So again, if I go to my note sheets, my double angle identities, the sine of 2x is 2 sine of x cosine of x. Cosine of 2x, I actually have 3 different formulas. They're all Pythagorean identities, which are switched around. So cosine squared minus sine squared, if you like, 2 cosine squared minus 1, or 1 minus 2 sine of x, or sine squared of x. Doesn't matter which one of those 3 you use, you should get the answer with any one of those 3 formulas. Tangent of 2x is 2 tangent of x over 1 minus the tangent squared of x. So again, you're going to want to keep these identities handy. I'm going to write them on my paper so I don't have to flip back and forth all the time. And so look back at those while we're working our problems out. So here, if we go back to find the sine of 2x, cosine of 2x, and tangent of 2x, if we know the cosine of x is negative 4/5 and x terminates in quadrant 3. Drawing our reference triangle like we get to do a lot. Over here in quadrant 3, we know that cosine is adjacent over hypotenuse, so we have negative 4 and 5. We need to find our other side. Negative 4 squared plus b squared equals 5 squared. This is 16, this is 25. We subtract, we get 9. The square root of 9 is 3. This is going down, so I would have a negative 3 for the length of that side. So, using 3 different formulas, starting off with the sine of 2x. If you look that up on your paper, sine of 2x is 2 sine of x cosine of x. So I'm going to have 2 times the sine, which is negative 3/5, times the cosine, which is negative 4/5. And then I'm just going to multiply that out. So I am going to get 24 over 25, and it's going to be positive. And that is going to be my first answer for the sine of 2x. Then I am going to do the cosine of 2x. Again, you can use any one of the 3 formulas. I'm going to use cosine squared minus sine squared. So, the cosine was negative 4/5. Take my negative 4/5 and square it, minus my sine, which was negative 3/5. Got to square that. So I am going to here get 16/25 minus 9/25. And if I subtract 16 minus 9, I get 7/25. And that's my answer for cosine of 2x. Lastly, we're going to do tangent. And if you look up on your paper, we are going to have 2 tangent of x over 1 minus tangent squared of x for our formula. So tangent is going to be opposite over adjacent. Negative 3 over a negative 4 would be a positive 3/4. So I'm going to have 2 times 3/4 over 1 minus 3/4 squared. So this is going to cancel. I'm going to get 3 over 2 on top. On the bottom, I'm going to have 1 minus 9/16. Making my equivalent fraction, I'm going to have 16/16 minus 9/16, which is 7/16. So I have 3 over 2 over 7/16. I have to invert and multiply. So I'm going to multiply by 16/7. 2 goes in there 8 times. 3 times 8 is 24. 7ths then would be my answer when I simplify. It's going crazy on me. Number 14 then, same kind of thing. Find the sine of 2x, cosine of 2x, and tangent of 2x if the tangent of x is negative 2, which means I have negative 2 over 1. Quadrant 4 is where we're at. So quadrant 4, we are going to have tangent, which is opposite over adjacent. So we're going to have negative 2 and 1 there for our two sides. And then we have to use our Pythagorean theorem. So 1 squared plus negative 2 squared. 1 plus 4 is 5. We're going to have the square root of 5 for our hypotenuse. And of course our hypotenuse is going to be a positive. Once we have our reference triangle, we can go ahead and find all our double angles. So sine of 2x is 2 sine of x, cosine of x. So 2 times the sine. The sine is negative 2 over the square root of 5. And the cosine would be 1 over the square root of 5. Which means I am going to get negative 4. Here I'm going to get square root of 5 times the square root of 5, which is the square root of 25. And the square root of 25 is just 5. So I get negative 4/5. Cosine of 2x. Cosine of 2x, again, I'm just going to use cosine squared minus sine squared. You can try one of the other ones if you want. Cosine squared minus sine squared. And so my cosine was 1 over the square root of 5. And square that minus negative 2 over the square root of 5. I've got to square that. So when I square this, I'm going to get 1. When I square the square root of 5, I just get a 5. Right? I get square root of 5 times square root of 5, which is square root of 25, which is just 5. Minus a negative 2 squared is 4. And again, when I square my square root of 5, I get 5. So I have 1/5 minus 4/5, which is negative 3/5. I need a little bit more room for my tangent, but I'll sneak it in there. Tangent of 2x. We said was 2 tangent of x over 1 minus tangent squared of x. So 2 times the tangent. The tangent was negative 2. It was negative 2 over 1, which is just negative 2. And 1 minus the tangent squared. So 2 times negative 2 would be negative 4. This is going to give me 1 minus a negative 2 squared is 4. So I get negative 4 over negative 3, which is a positive 4/3 for my tangent of 2x. I'm going to go ahead and move the board up so I have a little more writing room. I'm not way on the bottom. If it lets me. There we go, 15. So 15, we are in quadrant 3. So drawing my reference triangle over here in quadrant 3, the sine is the opposite over hypotenuse, so negative 5/13. So negative 5 squared plus b squared equals 13 squared. So that's 25, that's 169. If I subtract, I get 144. The square root of 144 is 12. That's going backwards, so I'm going to have a negative 12 for the length of my side in my reference triangle. So sine of 2x is 2 sine of x, cosine of x. So 2, the sine is negative 5/13. The cosine is negative 12/13. Multiplying all of that together, Negative 10 times negative 12 would be positive 120. 13 times 13 is 169. So I get 120 over 169. Cosine of 2x. Again, I'm just going to use cosine squared minus sine squared, just because I like to use the same one. So cosine squared of x minus sine squared of x. My cosine is negative 12/13 squared. My sine, negative 5/13 squared. So this would give me 144 over 169 minus 25 over 169. And if I take 144 and I subtract 25, I get 119 over 169. And then lastly, the tangent of 2x. We're going to use 2 tangent of x over 1 minus tangent squared of x. Tangent, opposite over adjacent. I'm going to have a negative over a negative, so I'm going to use a positive 5/12. So 2 times 5/12 over 1 minus 5/12 squared. So in this case, the 2 and the 12 would reduce, so I get 5 over 6. On the bottom, 1 minus, this would give me 25 over 144. Making my equivalent fraction here, this would be 144 over 144. So 144 minus 25 is 119. So I'm going to have 5/6 over 119 over 144. I have to invert and multiply. So I'm going to multiply 144 over 119. I can reduce that a little bit. 6 goes into 144. 6 goes into 144 24 times. That went in there nicely. So I then have 5 times 24. 5 times 24 is 120 over my 119. So double angle identities there.